So I can hear what you're saying. You're saying to me, Ed, I'll admit it, I'm a bit of a nerd, right? I'm spending my time watching videos, learning how to make R. But I can't say everything I need to say just with numbers. There's more to life than numbers. And I gotta say, yeah, you're right. Let's learn how to create and manipulate logical and character vectors in R. So to this point, we have exclusively been working with numbers, assigning numbers to variables, performing operations on numbers, but R can handle more than that. We're going to look at using text in R here. So we're going to assign variables A, B, and C the values my, bring, and back. And let's take note here when we're assigning text value or characters or strings, some people like to call them, to variables, we're going to use quotation marks every time. And this is what will let the R evaluator, the interpreter, know that it's looking at character variable and not at something like a variable name. So we have my, bring, and back. If we take a look at them, we want to go ahead and evaluate A, B, and C. We can see they print out my, bring, and back, and those are vectors. You recognize the first value there of 1, meaning this is a vector of length 1, just like any other variable we assign is. So if we wanted to make a longer vector, we could just use our C function like we have before, my, bring, and back all together. Not too terribly complicated. One thing you can't do with characters that you can with those numbers, and it's actually just an example for a number of things you can't do, is addition. So error here in A plus B, a non-numeric argument has been supplied to a binary operator, and clearly those aren't numbers, those are words. Same thing would happen for subtraction and things of that nature. Now there's lots of methods within R for moving with and evaluating and touching and modifying text, but they work differently than addition and subtraction do on numeric variables. So we're going to take the time and look at some more of those exciting text functions later on when we need to make use of them. For the present time, just want to make you aware there are more things than numbers you can use as variables within R. Another thing is what we would call a logical vector. So to take a look at one of those, we're going to set D equal to the value true, false, true. And this isn't going to work unless I task a C out in front of this function. That's important to remember at all times. So we'll do that, and let's take a look at D. True, false, true. It comes out without those quotation marks. That's because those are logical values. They're a special case of an object within R, and they don't behave the same way as characters do. Now, these logical values can be used in a variety of ways in R. One thing I'm going to show you quickly here is you can actually use logical values to subset vectors the same way you would numbers. So let's set our variable E equal to a vector of my, bring, and back. And then let's take a look at E subset to D. You see we just get my and back. True is the first value in D, and so the first value in A, it gets returned, true. False is the second value in D, so we don't return that second value in E, and the third value in D is true, so we get back. So you can use that to take just pieces and parts of other vectors or other larger data structures, choose the things you want, leave the things you don't. That's a very frequent use of logical vectors. Now, you have to be careful when dealing with vectors of disparate types because they're going to have conflict with each other in certain cases. Let's evaluate if we concatenate E and D together, what happens. You'll see that we have quotations around the true and false values now, and those are actually no longer logical operators, they're just going to be characters. And you can see this because if we assign this to a variable, let's make this F here, and we can use the class function to see what type of variables we're dealing with. So the class of F is a character vector, and the class of E is also a character vector. Now the class of D is a logical vector. So there are different types of objects. If you lose track of yourself or you get code from someone else and you want to make sure you know what the objects are, the class function is a very quick and easy way to do that. Now if we pass the arguments to that C function that we're assigning to F in a different order, D first and then E, and then we evaluate it, let's take a look at what F is now. Same thing. And that's called coercion, right? It's a different order, but they're both still going to be a character vector. We can ensure ourselves of that once again by calling our calling our class function. And what's happening there, like I mentioned, is called coercion, and that is when you are taking one type of object, so a numeric or a character, a logical vector, and making it into another type of object. There are a series of functions you could use to explicitly cause coercion, changing the types of variables you have. But there are also a variety of contexts in which R is going to perform the coercion for you as part of some function that you apply. So coercing variables into other types, or variables being coerced into other types without your knowledge, can be a source of trouble for you. It can also be a source of great convenience. It's just something to be aware of as you are creating programs and performing your data analysis. So that's a very basic overview of character vectors and logical vectors within R. There are any number of subtleties and wrinkles to these things that we'll sort of pick up as we go along, but these are just the basics. We know almost enough to be dangerous at this point, so pretty soon here we're going to start pulling in external data and doing some evaluation. And if you stick with me, you'll get to experience all that great fun.